Hollywood. See if any of them pick up. We're gonna make a box office movie about polynomial modeling. No, I couldn't. So anyway, polynomial modeling. Modeling means creating an equation that fits data. Now, I don't know if you've looked at your assignment or not, but take a quick look at your assignment. The first, 8 problems, you just have a bunch of points. But then the next 4 problems, aren't those tables of data? Like gold production, women's life expectancy. What we need to do is create an equation that fits the data. It's called modeling. It's actually a very, very useful thing to be able to do. Knowing how to do math is great, but knowing how to use math to model real-life situations is even better. And here's what we're going to have to do eventually. Turn it over to the backside. Take a look at number 16. 16 says, estimate the woman's life expectancy in the year 1982, or isn't that kind of what it says? Well, in order to do that, to answer question 16, you got to turn it back to the front, look at the table. We have to have an equation that matches that table. Okay? And that's the point of modeling. Once we have an equation, we can predict, we can make predictions. What's the life expectancy in 1982 or 2005? Okay? And we do that with an equation. Calculator does it really easy for you. That's why you need to have one. But to start, I'm going to remind you, and I do say remind because this is something I guarantee all of you have done before at some point in Algebra 1 or pre-algebra. Do you remember getting 2 points like this and you had to make a line or make an equation of a line that goes through? Raise your hand if that sounds remotely familiar. I know all of you have done this at some point in your life. Does this look familiar? Y equals mx plus b? Well, m stands for slope, b stands for the y-intercept. So in order to find an equation that goes through these 2 points, we have to know the slope. And eventually we're going to have to figure out the y-intercept. So now this isn't what you're going to have to do on today's assignment. The calculator is going to do it all for you. I just want you to remember that at some point you could have done it by hand. What is this right here? That's the equation to find what? The slope. This is the slope equation. Not to spend too much time on it because we're not going to be doing this by hand anyway, but it's still kind of good practice. Where do all these dang numbers come from? x2, y1, x1, y2. Where do they come from? They come from the 2 sets of points. Which one's which? Is this an x or a y? What about this one here, x or y? This one then must be a y, and this one must be a y. Now since this is the first point that I have listed, I'm just going to call that one x1 and y1. This then would be x2 and y2. So then y2 minus y1 is negative 12 minus negative 4. And then x2 minus x1 is 4 minus 2. Negative 12 minus negative 4. Minus a negative is the same as plus. So it would be negative 8. And then 4 minus 2. 4 minus 2? Good job, you guys. 4 minus 2 is 2. And then negative 8 divided by 2. You continue to amaze me. Negative 4. What is that, by the way? Negative 4 is the slope. So we know what m equals. The negative 4 goes right in there. What haven't we found that we need to find? That pesky y-intercept. I'm going to show you a way that you might not have learned back when you learned this the first time. The way that you probably learned, if I'm making the correct assumption, is you probably learned this form that y minus y1 equals m times x minus. Does this look familiar? Well, okay then.
That's the way it's usually taught in Algebra 1. Do we at least all agree that we're trying to find b? We all agree?
Now, this is an equation right here, right? Y equals mx plus b. That's an equation because it has an equal sign. We can't solve for one variable if we don't know all the other variables. Okay? But if we knew what m equals and what y equals and what x equals, couldn't we find b? Well, we know what m equals, right? What if we knew an x and a y we could use to help find b? Do we know an x and a y? Just use one of the points. Doesn't matter which one. It could be the same in the end.
So I'm going to use this point for an x and a y value. I'm going to use the b value, or the m value that we already know. So y is going to be -4. I'm using this y value right here. What was m? Now if I'm using this point, what do I use for x? Now look at this. We have an equation with only one thing we don't know, b.
So what is b? If you add 8 to this side, if you add 8 to -4, you get 4. So b equals
4. We now know what m equals. M was right here, -4, and we now know what b equals, +4. So the equation becomes y equals -4x plus 4.
That's what you were supposed to have done like 3 years ago in your algebra class. Okay. I can show you how to do this on a calculator. So I don't know if it's any quicker, but at least it can be done. You ready to watch and follow along? Now you can't just watch me do this and expect to know how to do it. You got to actually participate. So first thing you do is turn your calculator on. I'm going to turn my calculator on. Does anybody need help turning their calculator on? Okay. Now I'm going to go to the home screen. Here's the home screen. Raise your hand if you've used Microsoft Excel at some point in your short lives. Okay, so your calculator has kind of like a Microsoft Excel spreadsheet. Go to Stat. Has everybody found it? Does your screen look like this? Again, I only want to have to try to explain this one time, so put down all of the other goofy distractions. Now, we want to edit. So hit enter on edit. This gives you what are called lists. This is list 1, this is list 2, list 3. Does everybody's screen look something like this? Okay. Now, if you have numbers in your lists, you need to get rid of them, and here's a quick way to do it. For list 1, for example, if you scroll all the way up to where that L1 is highlighted and hit clear, and then scroll down, it clears out the list. So clear out all your lists. Screen should look like this. Am I okay to move on? Okay. What you're going to do is you're going to type in all of your X values into list 1, all of your Y values into list 2. Essentially, we're creating an XY table. You guys following? We have to have the X is in L1, the Y is in L2. It's like we're making an XY chart. So, my first X number was 2, my second X number was 4. So you have to type in the number and then hit enter. Now I'm going to type in a 4 and hit enter. So there's all the numbers in the X column. Now scroll over, do the same thing for your Y values. The first Y value was -4, hit enter. The second one was -12, and hit enter. Now the one thing that you have to make absolutely sure of is your X's match up straight across with your Y. Does 2 match up with -4? Yeah. 4 matches up with -12. Now I don't know how those Casios are working. Are you following along okay? Okay. We're good? Now, just for a moment, go back to your notes. You need to write this down. Finding an equation that fits data is called regression. regression. Okay, there's still a couple more things to write, so stay with your notes for just a minute. There's different types of regression depending on what kind of polynomial you want. If we just have 2 points, what's the quickest way to get through 2 points? What's the quickest distance between 2 points? A straight line, right? That's an example of what's called linear regression. Okay? Oh, let me get a blank screen here. What if we didn't have 2 points? What if we had like these 3 points? I don't know, right over here. Would a straight line go through 3 points? So it wouldn't make much sense really to try to find what's called linear. What do you think the word linear means? Straight line. It wouldn't really make much sense to try to do linear regression if we have 3 points. You following? So there's different types of regression depending on what kind of a polynomial you want. So let's list these. There's linear regression. Linear regression is going to give you a degree 1 polynomial. It's really important that you understand this. Look up here at where my mouse is hovering. Isn't this the equation that we came up with? And isn't this a degree 1 polynomial? That's called linear regression because we ended up with a straight line and it's a first degree polynomial. You following? Okay, if we have 3 points though, you don't want linear regression, you want quadratic. The best type of polynomial that goes through 3 points is a quadratic. That's degree 2. Are you noticing a pattern between the number of points and what type of regression that you're supposed to use? So if we have 2 points, what kind of regression you want? Linear, degree 1. What if you have 3 points? You want quadratic, that's degree 2. What's the pattern here? It's always 1 less than the number of points given. Right? So what if instead of 3 points, I give you 4 points to try to make an equation for? With 4 points, you're going to want cubic regression. That would be a degree 3. And if you happen to have 5 points, I don't know if you do on your assignment, but it might happen. If you happen to have 5 points, you're going to want what's called quartic. That's degree 4. This is actually very important to remember because your calculator needs to know what kind of regression to do. You can't just say find the regression. You have to tell it, well, find the cubic regression or find the linear regression. You have to give the calculator the right directions. All right, you with me now? So go back to your calculator. Once you've typed in the points, now you got to think, all right, I've got 2 points. What kind of regression do I want? Linear, here's where you find it. And this is where you've just got to follow along because there's a couple buttons to push. You ready? I'll try to go real slow. Press stat again. Okay. You see how it says calc right across the top? Scroll over into that menu, the calc menu. I don't know where yours is on Casio. Have you found it? Whoa, cool. Okay, awesome. Now, you see where it says all this REG stuff? What do you think that means? Regression. Which one do we want? Linear regression. LinReg for short. So hit enter on that. Now, depending on how recently you've updated your software, your screen might look like this. This is the most recent software update. Okay. Raise your hand if yours does look like this. Just curious. You guys need the rest of you need to update your calculator. So, if you have a TI-83 or an 84 that hasn't been updated, then your screen probably just says linreg, ax plus b. That's okay. It'll still work.
I'll show you both ways. If yours says this, I mean, it's basically the same thing. And I'm supposing the others look like this, right? Okay. The first thing your calculator needs to know is which lists
did you type your numbers into? Which list did we type our numbers into? L1 and L2. Now that's the default, and so if you have the new software, it puts those in automatically for you. The X list was L1, the Y list was L2. If you've got the old software, you've got to type those in
manually. So is your cursor right here? Yeah. Okay, so where the cursor's blinking, you're going to hit second and then the number 1. Did it give you an L1? Okay. Now hit the comma button. It's right above 7. Hit comma. Now you got to hit second and the number 2. So your screen now should look like this. L1, comma L2. Does it look like that? Okay, good. If you have the new software, it looks like this. Hit enter. If you have the new software, you got to keep hitting enter a couple of times. And look at that!
Comma's right above 7. So here's what the regression tells you. The equation looks like y equals x plus b, and then it gives you the a value and it gives you the b value. So what is the equation? Y equals negative 4x plus 4. Right? And we found out by hand. We knew it was going to be that, but the calculator tells us. Now, just raise your hand real quick if you have those r's. Who has the r's? Nobody? I'm talking about these right here, the r squared and the r. I need to see who has them, because we do actually have to use these later on in the assignment. Ooh, not a lot of you do. Oh, mama. Okay. This is kind of hard to explain. Who has the new operating system? The screen looks kind of like mine. Okay, here's how you turn on the function to find r's. Hit mode. And scroll down to the next page. If you have the new operating system, does your screen look like this? You see where it says Stat Diagnostics? Those need to be turned on. Yeah. You have the new operating system? Ooh, you got the new one. Okay, if you have the older operating system or a TI-83 or an 82, here's how you can do the same thing. Hit second. Please follow along with this so I don't have to explain it 2 or 3 times. Hit second and then 0. Do you have a catalog on there? Yeah. You've got to scroll down through a whole bunch until you find the stat diagnostic. So just keep scrolling down. Actually, you know what? You can skip all the way down to it if you hit. Where's the letter S on your calculator? I can't find it. Hit LN, and it should skip to the S's. Did. So you need to find, what are we looking for? Stat. Oh no. Are we not finding a stat diagnostic? Oh, it was in the mode? Do me a favor, everybody that's got a TI-84 or 83 or an 82, hit mode and then scroll down to the second page. If you have that stat diagnostics, you can just turn it on straight from there. You don't have a second page? What do you guys have, 83? Do you have the catalog? Well, I don't know where it would be then. Let's see. Maybe it's in the D's. Oh, there it is, diagnostic. It's in the D's. So catalog, and then go down to the D's, and you want to turn the diagnostic on. Second and then 0. And then go down to the D's for diagnostic on. Did you find it, Shalea? Did you find it? You found it? Did it turn on? Okay. Did you find yours? Now, once you've turned the diagnostic on, let's just do that regression one more time to see if you get those R values. So, I know I've only shown you once. Do you remember how to find that regression line? Nobody? You go to Stat, and then go over to Calc, LinReg. Now you might have to manually type in L1 and L2, or just keep hitting Enter a couple of times. Now hopefully it gives you those R values. Did it? Okay, here's what they mean. Really the one that matters most is the R squared. If R squared equals 1, that means you have found a perfect fit of a polynomial that goes through your points. Now for a straight line, it's always going to be a perfect fit because between 2 points, you can always put a line between them. We're going to be doing things later on maybe that you're going to have to compare which polynomial is the best fit. So it's going to ask you to do like a cubic and a quadratic model, and then it's going to ask you which one's the best fit. How do you know which one's the best fit? Well, you got to look at your R squared. The closer it is to 1, that's the better fit. So what if one R squared is 0.5, the other one's 0.7? Which one's the better fit? The 0.7 one. That's called the correlation coefficient. Yeah. Being weird?
Yeah.
What's weird about it?
Like I went into diagnostic, it showed the diagnostic on, and I did the like they told me to do it, it said that error on.
What? Is that what you're saying?
Yeah, okay. So that to diagnostic on each time.
Yep. What's on its own? Oh, you cleared it. Just keep hitting enter a bunch of times.
It's not showing the average stuff.
And then we're and now we're down to the second one. Comma. 2 plus 2, 2. You have to turn it on every time. Or should it show?
Oh.
Yeah. Okay, try it again. Okay. Let's go to number 8 on your worksheet. Number 8. Did it work now? Sweet. Okay, so how many points on number 8? There's 4 points, right? So what kind of regression? Cubic. You always do one less. So what do we do? Where do we go? We go to Stat, Edit. We got clear the lists. Remember, you highlight the list, go up to the very top, highlight it, hit clear, then scroll down. Now all of your X values are going to go into list 1. So you type in a 0, a 2, a -1. We're on problem 8. And then into the L2, you got the Y values. Now just double check that your X's and your Y's line up. 0, 9, 2, 21, -1, 0, and 3, 36. Are those the right points? Okay. Well, what are the directions even? What are we even doing here? On 1 through 8. Find a polynomial whose graph passes through. That's regression. We're trying to find regression. What kind of regression here? Cubic. Where do we find it? Stat. Calc. Now we want cubic regression. And if you have the older software, you got to type in L1, comma, L2. If not, just hit enter 3 or 4 times here. Boom! Look at that. What is it telling you? It tells you the equation. So how do we answer number 8? We can't just say A equals 1, B equals -2. We have to write the actual. So it's 1x to the third. Y equals 1x to the third minus 2x squared plus 6x plus 9. That's the equation that best fits those 4 points. Now, I get the feeling most of you know what to do here, and that's great, but I really want to make sure that we actually understand what we're doing here. Okay? So please listen carefully to this question. These 4 points on number 8, if you plotted those 4 points on a graph, can you guys imagine what I'm talking about? And then you graphed this equation on the same graph, what would happen? This equation would pass through all of those points exactly. Do you guys understand what I'm talking about? How do we know that it passes through those points exactly? What's the r squared value? 1. The r squared value is 1. That means that this equation passes through all 4 of those points exactly. This is what regression is. It's trying to find an equation that passes through points, or as close as we can get to it. We okay so far? Okay. So that's what you do on 1 through 8. Let's skip down to number 10. We have a table of values, but isn't a table of values just like a list of points? But you have to understand there's one slight difference you got to pay attention to, so please, before you start typing away. What does it say for number 10? Let x equal the number of years after 1970. It's so important that you understand this, Colton, and that you're not texting on your phone, Colton. Okay? Because here's what a lot of students would like to do on number 10. They would just use all of those values that are in the table and plug them into the calculator. But you're not going to use 1970 and 1980 and 1990. It tells you what to use for x. It says let x equal the number of years after 1970. There you go. So that first data point, 1970, comma 74.7, how many years after 1970 is 1970? 0. So for that point, what's your x value? 0. And then the y value is 74.7. You guys following? So when you go to your table, so go to Stat, Edit, Clear List. So for L1, the first x value is 0 because 1970 is 0 years past 1970. What about 1980? 10 years, 1990 is 20, and then 2000 is 30. So those are the actual x values. Your y values, you can just use the y values that are given there. What are these? Ooh, the female life. Look at that! Look at that! You guys your life expectancy is going up. What do you think that is? Better health care? I don't know. Maybe the depletion of the ozone, is that helping your life expectancy go up? I don't know. By the way, females have a much higher life expectancy than guys. Why is that? No. I tell you, I had to stay home a couple of days to watch my kids. That is hard work. I'd rather be here. Anyway, I don't know. Guys just have a lower life expectancy. That's exactly probably most of the reason they do stupid stuff. Hey, let's ride this four-wheeler off the cliff. I'll survive. It'll just be a scratch. On number 10, it says let x equal the number of years after 1970. So 1970 is 0 years after 1970, right? 1980 is 10 years after 1970. Say again. Decimals? Who? What? Who's getting decimals? Oh, hold on. You guys are way ahead of me. 97.7. What? Oh, I got something wrong? 78.8. And then what was the other one? Oh. Well. Alright, anyway, so go to stat. Tell me what to do, stat. Calc. How do we know it's cubic? There's 4 data points. We want cubic regression. Type in L1, L2. Enter, 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 enter. Holy Moses Malone. Raise your hand if you know what scientific notation is. You all should if you've taken Mr. Bastian's chemistry course. That's what this is right here. You see this little e? That means times 10 to the negative 4. So it's really not 1.333. Do you guys understand how scientific notation works? What does it mean that it's negative 4? You move it to which direction? To the left. So you are going to get a bunch of weird decimals for those tables. So here's what you do. I want three decimal points. So your equation for this one, I guess your first one's going to have a few more than 3 decimal points because you got to move it to 4. Here's what I want to see for number 10, the equation. Y equals 0.00013. Why do we have to have all those zeros in there? Because you're moving it 4 spots to the left. So that's your x to the 3rd coefficient. What about your x squared coefficient? Minus, what is it? 0.105 x squared plus 0.3617, I guess we want to round up, 0.3617x plus 74.7. That's how you answer number 10. Now, you guys remember what I said right at the very beginning? Finding an equation is great, but what is the equation actually useful for? Just staring at it? Exactly. Did you guys hear that? This table that we have only gives us a life expectancy in 1970, 1980, 1990, 2000. What if somebody asked us, well, what was the life expectancy in 1986? Does the table help us out with that? No, but the equation will. You guys understand what I'm saying? Because that's number 16. Take a look at number 16 on the back side of the worksheet. Number 16 says, estimate the life expectancy for a woman born in 1986. Well, how many years after 1970 is 1986? 16. So let me give you a couple of options on how you want to answer these questions. Here's option 1. Listen carefully. You could take your equation. Right here, isn't this your equation? And if you're trying to figure out the life expectancy in 1986, what would you use for x? 16, right? So you could take the equation, type in a 16 for all the x's, and figure out what it all turns out to be. Does that sound like a very nice or an easy thing to do? I wouldn't do it that way if it were me. The point is it could work though, right? What about the next question? It says, what about 1992? What could you plug in for x for 1992? 22. Right? Still not a very easy thing to do. Let me give you a second option, and this is exactly the way I would do it. You need to turn on your imaginations, right? What if we were to graph that equation on our graphing calculator? You following along? And then instead of putting in 16 for all the x's manually, what if we just hit trace and traced over to where x equals 16 on the graph? What would that tell us? Your y value would be the life expectancy. You guys following? Doesn't that seem like a little bit easier thing to do? Now, the one thing though is, if you go into y equals, you'd have to type in this equation, right? Which isn't that hard to do, but if you miss like a decimal point somewhere, or if you goof up, it's not going to give you the right answer. You following? Your calculator can copy and paste this equation from the home screen to the y equals menu. Are you interested in learning how to do that? Okay. Go back to your home screen. You there? So you got to go through that whole process of the regression equation again. But there's one small difference. So follow along with what I'm doing. You ready? Go to Stat. How do you find the regression equation? Calc. Which one do we want? Cubic. Now here's the difference. Okay, I'll first show you the difference if you have the old software. If you have the old software, you still need to do this.
Well, yours is going to say cubic right here. It's going to say cubic, regression, L1, L2. Before you hit enter, you're going to put another comma. So if you have the old software, get to that point. L1, comma, L2, comma.
No, we haven't typed anything into L3, so we're not going to use L3. That would be a third. That would be a 3D graph, yeah. Those that have the old software, are you to that point? Okay, if you have the new software, hit enter, enter, and then hit enter again to where your cursor is on that store reg EQ option. You with me? Now, whether you have the old software or the new software, from here on out it's the same. You do the same buttons, or you press the same buttons, okay? So, you ready to watch? Hit vars right here, V-A-R-S, hit vars. And scroll over to Y. Var stands for variables, Y variables. Scroll over to the Y variables. We want a function. We want the calculator to do a function. So hit function. And where do we want the calculator to put the function? Into Y1, don't we? So hit enter on Y1. Now if you have the new software, now go down to calculate. If you have the old software, just hit enter. And it still calculates the regression like normal. But now the difference is when you go into your Y equals, take a look at what it did. It copied and pasted it into your Y1, because that's where we told it to put that function. So now, if you hit graph, now this is not showing me the entire picture, and that's okay. Yeah. Here's what I want you to do. Hit the zoom button. And we've been using the stat button a lot, haven't we? So go down a couple of options to where you see something that's called zoom stat or Z stat or something like that. It's called zoom stat. I want to see what happens if you hit enter on that. Hit enter on zoom stat. Does it show you something kind of like this? Still no? What does your screen look like? Didn't change? All right, go back to zoom. Let's try another option. Go down to zoom. Where are you? Zoom fit. Let's try zoom fit. Hit enter on zoom fit. Does it look a little more like this one? Now here's what I was trying to say about once you have the graph, just hit trace. And then we want to find out 1986. So after you hit trace, type in the number 16. And hit enter. What does it tell you the life expectancy is? 78.34 years. Much easier than having to type something into the equation, right? What about 1992? What would we type in? So type in 22 and hit enter. What was the life expectancy in 1992? 78.99 years, yeah. Who's saying error message? All right, here's the problem. It's not a problem, really. If yours says an error message, I want you to hit your window button, and I'll explain what the problem is, too. Look at your X max. If you had an error, what is your X max set to? So the problem is you're trying to find something that's beyond your X max. Because if you're typing in 22 or 16 and that's beyond your X max, it's going to give you an error. So you got to change your X max to just something a little higher to type in higher values. So I put mine at 40. And then you hit graph. And then if you hit trace, now you can type in higher values of X, like 16 or 22 or whatever. Okay. No. Nope. Well, this is what your assignment is. Good? Any other questions? We good? Any questions? You figure out calculators? So again, if you hadn't have had a calculator, this would have been impossible, right?